next 7 Caillou challenge is called Cats and Shelves. So the idea here is that you have to help this cat navigate up these shelves, if you will. And notice how they're staggered. So you've got odd numbered shelves. They alternate. It goes, odds on the left, evens are on the right. 1, 2, 3, 4, 5, 6. And so what you need to know is that the cat's jumping ability, it can span 3 floors. Notice how it's starting on 1, and with a maximum jump, it can get up to 4, which would be a difference of 3, right? 3 floors. But the catch is that it needs to jump to the other side to fully utilize its jumping power. If it tries to get to level 3, for example, it can't. The bang represents the cat banging its head, and it can't even get off the first floor. But it can do, it could jump to 2 and then 3 to get to 3. So that's the idea. And then you have to find the number of jumps for the cat to get from the start to the finish. Note that the cat won't necessarily start on floor 1, it could start on 4, and that in theory there are an infinite number of these. So don't assume it's just from 1 to 6 here. It could be from 43 to 87, for example. And so I think you have everything you need to know. They give you a couple examples here. Consider start as 1, finish as 5. The answer should be 2. And we could step through that together. You're going from 1 to 5. Note with a max jump, the cat can get to 4. And then with its second jump, it could take just a 1/3 jump, if you will, but it still counts as a full jump to get to 5. That's why the answer is 2. 1, 2. So yeah, go ahead, pause the video. I'm going to format this to my liking, and then I'll go into a solution. So let's get started. Just for starters, if you want, you could go console, right line, oops. And we can just print out these variables. They may be helpful while testing. Finish, finish. Okay. And let's do some work here. So the way I went about this, I like to think about this almost like an elevator where you're always going up. In this case, you're going up floors with these special little catches with the side thing going on. And so in general, think about an ideal scenario. Let's say I have to go from floor 1 to floor 100. I use sort of a greedy algorithm approach where I always take max jumps going back and forth from side to side. So I would go from 1 to 4, 4 to 7, 7 to 10. You know what I mean? Zigzagging my way up. As long as there's room ahead, I'm taking a full jump and going to the other side. So a way I can express that, I would say int, I'll call my num jumps, and that'll be my result too. And so what I want to do is take the finish minus the start, right? This expression right here defines my range from my start to finish, the range, the number of floors I need to traverse, to climb. And so that's my range. And then I'm going to divide that by 3 because that's my max jump, right? I'm always taking that max jump to get there. And so as you can imagine, this doesn't necessarily work out evenly, right? Imagine I'm going from 1 to 5 like in the example. Sure, I can jump 3, but then I'm not jumping 3 again, I'm only jumping 1. So let's modify this a little bit to work. One thing that I'm going to note is that any jump, regardless of if it's 1 floor, 2 floors, or 3 floors, it still counts as a jump for these purposes, right? So what I want to do is I'm going to take the ceiling of this expression. That's why I use 3.0f here. I converted this into a floating point. I didn't just use 3 here. If you do this, ignore my math ceiling for the moment. But if I run what I have highlighted here, it's going to truncate because these are all integers. It won't have any decimal portion to the answer. But when I convert one of the operands to a floating point, now it executes this whole expression using floating point arithmetic, and I will get the decimal part. So consider that, you know, I could have a remainder here, like went from 1 to 5, I jumped to 4. I had to make a second jump, you know, like 1/3 of a jump. And all the ceiling is doing is saying to round up, right? Because when I went from 1 to 5, that'd be a difference of 4. If I divide by 3, I get 1 1/3. And that 1/3 is actually going to round up to 2, which is good, right? Because we need 2 jumps to get from 1 to 4. Even if you're just that little bit off, you still need to count another jump that you have to make. So that's sort of the basis, and it covers us a lot of the time. But we also have to address this idea of the cat possibly getting stuck and not being able to necessarily, well, here, let's return num jump so you can see what I mean. We'll put this in, we'll hit test. It'll probably work sometimes when we get lucky where everything is on the right side. Oh, sure. So it's telling us console does not exist. If you recall, hopefully the namespace that console's in. Remember, we didn't make console, so we have to say using system. That'll bring in the system namespace in which console is defined, and also its right line method. So, and system will also cover math because we used math ceiling. So system's quite handy. Lots of good features there. Let's hit test again. Ambiguous call between ceiling. Oh, yep, I totally did that. I wanted to pass this whole thing as the parameter, right? We got to do the division, and then I want to round up. So yeah, sorry about that. I missed the parentheses there. I should also note too that because of order of operations, I enclosed the finish minus start with parentheses. If I didn't, it would take start divided by 3.0f first, because division has a higher order. It takes precedence over addition and subtraction. So we got cannot implicitly convert. That's fair, right? If you look up the docs for ceiling, you'll notice that method returns a double, and we're trying to assign it to an integer. And so what we can do is just a simple C language style cast here, and just say, hey, take this double, make it an int, and then you can see how int matches int, and the compiler should be happy. Okay, so we had some simple tests here and we got lucky. It worked out. I'll hit the attempt for you so you could check it out. But yeah, consider these two cases they gave us. 1 to 5, we saw it worked, right? 5 minus 1 is 4, divided by 3 is 1 1/3, round up, you get 2, and that's the right answer, 2 hops. And the other one was 2 and 5. So if you're on 2, 5 minus 2 is 3, 3 divided by 3 is 1, the ceiling of 1 is 1, and yeah, the cat can certainly jump 3 floors and get there in 1 hop. So hopefully this illustrates a good point though about testing, unit tests and things like that. Your unit tests are only as good as the coverage you give them. You know what I mean? If you write overly simple unit tests, I could walk away and say, I passed all my tests, I have a great solution here, when clearly this is not the right solution. So make sure you're hitting edge cases and all the cases you can imagine when you're writing these tests. And I'm not faulting these guys, they have a larger collection here for the attempt button. I thought it was a good time to make that point. You want good solid coverage. And similarly, if you write a lot of bad tests, or tests that are kind of that do the same thing, you can have a million of them. If they all check the same single case, you're not covering all cases and you don't have the coverage you need. But anyway, here we go. We hit the larger collection. We hit our first failure with 27 and 71. You could see we were off by 1. Again, off by 1. Here's a simpler example that we can use our drawing for. Let's look at 2 and 4 and see where we went wrong. So you've got 4 here. Now we're starting on 2. So we take finish minus start. 4 minus 2 is 2. Divided by 3 is 2/3, right? And when you round up 2/3, you get to 1. So our number of jumps was 1. But we know if the cat makes 1 jump to 4, it goes bang, it can't get there. It actually has to go to 3 and then 4. So there's a problem here. And the way I'm going to address this is I'm going to note which side the start and the finish are on. And we can do this. I want to know if they're on the same side or if they're on opposite sides. And a way I can achieve that, I could say, oops, bool same side. And we could use our modulo operator to find out if they're even or odd, right? If start modulo 2 is equal to finish modulo, wow, really fat fingering there, modulo 2. If that's true, then, you know, they're either both even or both odd. Either way, I could say they're on the same side. If this condition does not hold, if they're not equal, that means one evaluated to 0, the other evaluated to 1. That means they're on opposite sides. And so with this information now, I can possibly bump our number of jumps as needed. Remember this 2-4 case, it only got us 1 hop to 3, and we can bump one more as needed. And so let me show you how we can do that. And by the way, at any point, if you want to pause me, if I say something that gives you an idea where you are stuck, pause me at any point and see if you can figure the rest out on your own. But anyway, so we'll do this. We'll say if same side and the number of jumps is odd, in other words, modulo 2 equals 1, we'll increment our number of jumps. We're going to do something similar for another case where we need this. If not on the same side, and if the number of jumps is even, we will also bump the count. So let's kind of walk through this and see if it gets us where we need to be. In the case of 2 or 4, 2 and 4 are on the same side, right? They're both even. So and the number of jumps that we had initially was 1. Remember, we did 2 divided by 3, rounded up to 1. So in fact, the number of jumps was odd. They're on the same side, and we had an odd number of jumps up to this point. So we're going to bump it up 1, and you get number of jumps equals 2. And if you recall from the output, we saw that the expected value is 2, so it should work there. And then it's we're kind of covering another case where we potentially would need a jump with this other statement. So I'll hit test. I suppose I could have went right for the attempt. Good. We can check at some of these logs if you want. I think this one might have had the larger failure case. But anyways, yeah, sometimes you needed, because of that little quirky thing here with, you know, it's not totally like an elevator. You got this idea of platforms on opposite sides that we had to deal with as well. So I had to bring this other logic in to give us that extra hop we need to get to the destination. So yeah, there's not really, I know this one was kind of more about problem solving than coding, but it's still good to practice that stuff. There's nothing I can teach you, right? Because every problem's different. There's no general thing I can give you that's going to solve every problem. This is something you just kind of have to power through. Sometimes you won't get them on your own. You watch people do it, you remember how they do it, and then you kind of have that little technique you can leverage for the next time you run into a problem. But you're gonna, you know, it's a lot of running into problems you just never solved before, and the way you get better at that is just through practice. You become more crafty, resourceful, that sort of thing. So yeah, I guess I'll leave it at that. We'll go ahead and submit. I'll get rid of my debugging statement. And then I should be clear to submit. They're going to make us run the attempt again. Good. Go ahead and look through other solutions as well. And again, you could have just put this bit here. You didn't need to make a local variable same side. I like doing that because it makes the code much more readable in my opinion. But you could have just inserted that logic right in here, or in this case, since it's negated, you could say not equals. But yeah, I like this. It reads a little bit better. Go ahead and submit. Get our honor points there, kata points, and yeah, there you go. This one's even more compact, so that's nice. Divided by 3 plus modulo 3. Cool. So yeah, you can find even better stuff in the solutions here. But anyway, I hope you found this useful. If you have any questions, feel free to hit me up. Otherwise, I'll see you in another challenge. Thanks for watching.